Hi, everyone. I'm Doug Black, editor-in-chief at Inside HPC. And today, for another of our ISC video interviews, we're talking with Chris Weber. He's firmware engineer at NetApp, and with Premal Savla, director of product management, deep learning systems at NVIDIA. Gentlemen, welcome.
Thanks, Doug.
All right, great to be with you. So, Chris, let's start with you if we could. NetApp and NVIDIA have been partners since about 2018, as I understand it. Could you talk a little bit about that relationship?
Yeah, like you said, since about 2018, NetApp and NVIDIA have been partners in a number of joint ventures. We're both very good at what we do. We're leaders in our respective markets. And, we've come up with a number of joint offerings. One of the ones that we're very excited about is NVIDIA DGX Foundry with NetApp. And we also have the NetApp ONTAP AI reference architectures, as well as some NetApp ONTAP AI integrated solutions. And the one that I'm personally very excited about is our newly announced NVIDIA DGX SuperPOD with NetApp offering.
Okay, great. And Premal, how about you?
Sure. So NVIDIA and NetApp partnership has been great for our customers. It allows our customers to leverage the best technologies for their HPC and deep learning infrastructure. And with NetApp's ONTAP AI, we provide customers an easy way to start small and as their needs change, allowing them to use a fully optimized solution and grow with it. With NetApp as a partner, we get to showcase both NVIDIA capabilities on the system and the cluster performance management, and we can leverage NetApp's expertise on the storage. And as you know, good data is a key enabler for AI and HPC success for our enterprise customers as they move into this new realm of AI and deep learning for their applications and workloads in the data center.
Yeah, so Premal, tell us a little bit about the DGX SuperPOD. Give us some detail and color on that.
Sure. So one of the things we do at NVIDIA is we dog food our own systems. And every time we launch a new DGX system with new GPUs, we actually build out a whole large cluster in-house, and we allow our internal users and researchers to test drive the system. And we learn how to create an optimized solution that will meet the DGX customers' needs in the next 12 to 18 to 24 months out. The SuperPod was built from this idea, first as a reference architecture and then as a product because our customers wanted it exactly like we built it. It's a modular design with a full non-blocking IB fabric of 200 gig NDR. We isolated the storage and the GPU traffic with separate, completely isolated and separate environments. And it's designed for all workloads from NLP to HPC to analytics to computer vision. These workloads have demanding storage needs, and we found that a parallel file system allows us to support a mix of capabilities from small files to large images to video streams, and it also supports the application capabilities, whatever read write requirements that they might have, and checkpointing, especially when we are doing multi day and multi week jobs. So the storage becomes an important factor in the cluster itself. NVIDIA provides all the necessary hardware and software required to bring this solution online very quickly, and customers get these from a single scalable unit of 20 DGXs to seven scalable units of 140 or more. And Selene, which was our internal cluster, is number six on the top 500 with 560 DGX A100s in them. So that, in a sense, is what is a DGX SuperPod, which basically is a full solution, fully vetted and tested solution that our customers get, and they can scale from 20 DGXs to 140 or more, depending upon what workloads they are trying to run on these particular clusters.
Okay, amazing. Um, Now, Chris, tell us about NetApp's decision to choose the BGFS and the NetApp EF600 all-flash NVMe storage system to be part of this solution.
Yeah, as Premal mentioned, a parallel file system is necessary to keep up with the workloads and performance that a SuperPOD requires. The compute is only as good as the storage behind it. If you can't keep the GPUs fed, you're just going to be wasting time and money there. NetApp has tried a number of parallel file systems out, and our parallel file system of choice is BGFS. And it was created to solve the pain points of some of the other existing parallel file systems out there. It's a software-defined parallel file system, so it's independent of any particular hardware. And it's owned by an independent vendor as well. So for some of those reasons, we tested out BGFS and found that it was really good. NetApp is a diamond partner of ThinkPark, who owns BGFS codebase, and we have multiple 10 petabyte plus deployments in the field today. And with the EF600 behind BGFS, we've optimized and tuned and made it very resilient for HA purposes, such that if any piece in the storage building blocks behind a SuperPOD were to have an issue or go down, your workloads will continue running. So you won't have to fail a job and try and restart. Everything will keep going behind the scenes there.
Okay, and Chris, sticking with you, tell us about NetApp's experience and success in the HPC market, especially maybe bring in some customer experiences.
Yeah, certainly. As I mentioned, NetApp is not new to HPC, and we have multiple BGFS deployments out in the field. We actually offer L1 and L2 support for BGFS. We've gone all in on this parallel file system. And, like I said, we're not new to HPC. There's a number out there. What it is new is that the AI workloads are coming along, and they mirror very much what a typical HPC workload would be. So, we found that, those workloads are very much similar. And one that we had just before going through the SuperPOD qualification efforts was the Simula Research Lab in Norway. And it actually has several DGX systems with a number of GPUs connected via NVLink. And the storage fabric is Mellanox, or NVIDIA Mellanox HDR InfiniBand, capable of 200 gigabits per second. And we have a tiered storage approach with this deployment, over 500 terabytes of enterprise hybrid storage, and then 85 terabytes of hot, fast scratch space storage for this one deployment there.
Okay, great stuff. Premal, talk a little bit about NVIDIA's HPC strategy and market positioning as well.
Sure. So at NVIDIA, as you know, we like to tackle the most difficult challenges. At GTC 2022 in spring, we announced the new H100 GPU that will be available later this year. And along with that announcement, we released updates to 150 different SDKs that are used by a lot of our HPC, ISVs, and our customers for their AI and deep learning applications. So if folks have not checked that out, they should look into and leverage these SDKs for their work. And I'm also super excited about the new Superchip Grace that we announced and introduced. And we will be introducing more capabilities around the Grace Superchip and the Grace and the Hopper GPU for this, particularly targeting the HPC space and seeing how they adopt it for their work. We have a lot of customers that have been using NVIDIA products for their HPC applications. We've been doing this for the last 15 years. and I'm super excited to see what our customers do as they leverage some of the new technologies and software and hardware that is being offered through NVIDIA.
Okay, very good. So, gentlemen, thank you both. Great to be with you today. Chris, tell us where our listeners, our audience, can learn more about NetApp.
Certainly. Folks can go out and learn more at netapp.com/AI and also www.netapp.tv.
Okay, and Premal for NVIDIA?
Sure. So for NVIDIA, come check it out at nvidia.com, and you can get all the latest details about what we talked about on our website. Thanks.
Excellent. Thanks so much to both of you. Thank you.
Thank you.